Okay, we're going to go over explaining the surds in this video. So we'll explain first what surds means. So the surds are rational numbers. So the surds are irrational numbers. So the difference between rational and irrational. Rational numbers is any number that can be written as a fraction, like 3 over 2, 5 over 2. 6 over 2, whatever. So the fractions must be an integer as a numerator and an integer in the denominator. Irrational numbers are numbers cannot be written as a fraction, like square root of 2 cannot be written as a fraction. Pi, we cannot write it as a fraction. Square root of 3, 2 square root of 3. So all these numbers are irrational numbers because you cannot write that number as a fraction. Again, fractions must be integers as a numerator and integers as a denominator. So the surds are irrational numbers, or numbers can be written in roots. So like square roots of 2, square root of 3, square root of 5, square root of 7. Those are all surds. Now, square root of 4, because you can find the square root of 4, which is 2, so that's a real number, not a surds. So all these numbers, so what we're going to learn today, how surds are just numbers at the end of the day. They are irrational numbers, but they are numbers. So you can add them, subtract them, multiply them, divide them. You can simplify them. So that's what we're going to learn, how to manipulate surds. So before we start manipulating surds, there is few rules that we need to learn. So the rule is, if you have two numbers multiplied together, to give you the square root of, or any roots, like third root, fourth root, but we mainly use square roots in level 3. So you can rewrite it as split them. So this will be the roots of the first number times the roots of the second number. Then division, again, you can split them. So it will be the roots of the numerator and the roots of the denominator, which is the same as the dividing. So that's what's the first two rules that you're going to have to remember. And we're going to use them when we simplifying the surds or rewriting the surds. So for example, if the first thing we're going to go through is simplifying surds. So how can you rewrite the surds? So first of all, we've got square root of 50, for example. You need to look for the factors of 50. They are square numbers. Square numbers means they are the numbers that you can find the square root for. Like 4 is a square number because you can find the square root of 4 is 2. 9 is another square number. 16 is a square number. 25 is a square number. 36 is a square number, and so on and so forth. So when you're simplifying surds, you're trying to find square numbers, factors as a square numbers. So 50 can be written as 25 times 2. So that means 25 times 2, that's times, not a multiplication. That's not a decimal point. Sorry, I'm supposed to change them. I forgot. So that's it's easier to write with the dots, that's all. So it's 25 times 2 and can be written square root of 25 times square root of 2. And the square root of 25, you can find a real number, which is 5. And that's why square root of 50 is the same as 5 square root of 2. Square root of 720. So you need to look for the square number that is a factor of 720. So it's 36 times 20 give me 720. 36 is a square number and the roots for that is 6, and 20 can be written as 4 times 5. So 4 is another square number. So, and that's why you can, square root number of 36 is 6, square root number of 4 is 2, and the square root of 5 is a rational number, so you can leave it as it is, and that's the answer is 12 square root of 5. Now to check the answers for these, you can always find the answer for this in the calculator, find the answer for the other one in the calculator, and just make sure, and you'll see they'll give you the same value. Now when you have variables or letters, obviously they're solving them will be slightly harder. So the numbers, the coefficients will be treated as it is. So 108, you look for the number that can be written, the square factors. Now 8 to the a to the power of 3, because you have a square root, so you need to split the powers, means you take the even powers, divide by 2 basically. So 3 divided by 2, 3 is an odd number, so that means you cannot really find the square root of 8 to the power of 3. But if you split it, 8 to the power of 2 times a, the a square, the square root of that is a, so you left with a under the square root. I'll just show you what I mean in here. So basically 108 is written as 9 times 12. And then that 12 will be can be expanded even further, because the 12 comes from 4 times 3. The a to the power of 3, I've written it as the even power, which is a to the power of 2, and a, b just an odd, and c to the power of 4 because it's even already, so I've left it as it is. Now I'll find the square roots. So now what I can find, so 9, square root of 9 is 3. Square root of 4 is 2. 3ab, that you cannot get them out of square root, so they mean to stay under the square root. Square root of a square is a. Square root of c to the power of 4 is c square. And the answer will be like this. And then obviously you multiply the 3 and 2, and that's where you get 6a square, ac square. Right. For this one here, slightly different. The first thing, obviously, you will have to factorize in here. But to factorize this easier is take the 3 as a common factor, because you can see the 3 is a common factor. So that's what I got left. And then I will factorize this because it's a perfect square. Now, if you don't remember how to factorize as a perfect square, there is another video, I think, in the same on my YouTube channel in level 1 to help you factorize as a perfect square. But I'll just go over it now very quickly. So perfect square is basically you divide the b, and then how do you know this equation is a perfect square? Basically, if you divide the coefficient of x and y, give me 2, square the 2, give me 4, and that's the constant, so that's a perfect square. So that means I can re-factorize this as x, y plus 2. So like this, all square. If you expand this, you'll get that one here. And now the 3 cannot be taken out of the square root, but the brackets can be taken out of the square root because it has an even power. And that's why the answer is this. Now multiplying surds. So when you multiply surds, you will have to remember your expanding skills in algebra. That's if you multiply. So for this one here, if you multiply, you can simplify those surds first, then you can further multiply them, or you can multiply and then try to find the factors. But it's easier to simplify first. So I can rewrite the 32 with 16 times 2 and 3 times 9. So I'm finding those two square numbers. Again, I'm simplifying it. So 2 times 4 is 8. Times 3 is 24. Now the square root of 2 and the square root of 3, both of them cannot be taken out of the square root, so when you multiply them, give me square root of 6. Now for this one here, that's what I'm telling you, saying that you will have to use your expanding skills in algebra, so you just literally expand. Again, before you expand, try to always simplify first, or expand straight away. It's really up to you. So for this one, I've expanded. Now I'm going to try to simplify. So I'm simplifying those further, and I end up with 6 square root of 10. This one here, you can see it's like exactly expanding 2 brackets. So you multiply the 2 square root of 5 times 3 square root of 5. 2 times 3 is 6. Square root of 5 times square root of 5 give me 5. and then I multiply this with that one, I got this, and so on and so forth. So I'm just multiplying each term by itself. Just remember, square root of 2 times square root of 2 is 2. And now, again, when you're adding and subtracting surds, you look for like terms. So the like terms in here, you've got square root of 10 and square root of 10. So those two are like terms, and obviously those are whole numbers. So they are just adding them. So simplifying this further, that's 30 and 12. Those are two numbers. So 4 minus 9, just using the like terms in algebra, same skills. That's give me the answer 18 minus 5 square root of 10. Conjugates. The next skills is learning about conjugates for surds. So this surds here is a combination of a real number and a surds, a rational number. So the conjugate for that is basically exactly the same, but changing the sign, so the middle sign. So this is the surds, this is the conjugate for that. So why we use the conjugate? Because when you multiply any surds by its conjugate, the answer always is a real number only, real component. So you can see the answer here with no surds. And the reason, because when you expand, you will have the two middle terms, which has the surds, are opposite signs, so it cancels out together. This is very useful because we use the conjugate with dividing surds, because when you divide surds, you will have to try to always get there. You will need to have the denominator as a real number as an answer. So for example, this is just how to multiply conjugates. So if you multiply those two conjugates, you will end up with a square of the first terms minus the square of the second term. So that's why, can you see, the answer for multiplying any surds by its conjugate is always a real number. So we use it in division. So you always multiply the fraction by the conjugate of the denominator. So the conjugate of this denominator, it's basically square root of 5 in here. So that's not really, because it has no two components, so it's not really, we don't change the sign. There is no middle sign in here. There's no two components. So you basically multiply by the negative square root of 2, and that will give you the real denominator, or the real number in the denominator, and that's your aim. So that's the answer. Now the next one, again, you multiply by this. You can simplify this further first, or you can just multiply by the square root of 7, and that gives you the answer. Now some people will say, no, I want to why didn't we multiply by the square root of 42? Yes, you can. It's just the number will be bigger, but you can still multiply numerator and denominator by the square root of 42, and then you will end up, by simplifying, you'll end up with the same answer. Now, if you have a denominator like this, can you see there is two components for this surds? This time you'll have to use the conjugate. So you multiply by the conjugate of the denominator. Now, when you multiply by the conjugate, you use your expanding skills. So the numerator just expanding, the denominator again, you're expanding, and you will end up with this answer. You can't, they are not like terms. You can't simplify those surds anymore. So you will have to stop where it is. So obviously you will have to simplify any further. You can't simplify the surds, but you can find the 20 as a common factor, and then you simplify the 20 with the 100, and that's your last answer. We'll do one more example. Again, you've got fractions of surds, or divide of surds, so you'll have to multiply by the conjugate of the denominator, and then when you expand normally, you'll get that, and then you'll get this as an answer. Again, they are not like terms, so you cannot expand any further, and there is no common factors.